In this video, we're going to be looking at more about angles, and we'll be looking at how to construct parallel lines, the sum of the measures of the angles of a triangle, the sum of the measures of the interior angles of a convex polygon with n sides, the sum of the measures of the exterior angles of a convex n-gon or polygon. Let's talk about what vertical angles are. Vertical angles are created by intersecting lines. Well, they're created by intersecting lines, but they are a pair of angles whose sides are two pairs of opposite rays. So in this case here, for this example right here, let's say we have two lines, L and M. And in this case, angle 1 and angle 3 are vertical angles, because those are a pair of angles whose sides are two pairs of opposite rays. And also angle 2 and angle 4 are another pair of vertical angles. Okay? Those pair of angles, those two angles are formed by opposite rays. Two pairs of opposite rays. And also vertical angles are congruent, meaning that angle 1 and angle 3 are congruent to each other. And also angle 2 is congruent to angle 4. Okay, so do be familiar with vertical angles and what they are, and the fact that vertical angles are congruent. All right, next is supplementary angles. Those are two angles whose angle measures add up to 180 degrees. So the sum of the measures of two supplementary angles is 180 degrees. So with this first set, you got one angle that's 140, another angle that's 40 degrees. If we add 140 to 40, you're going to get 180. Also, 50 degrees and 130 degrees, those two add up to 180. Also, 180 minus x degrees and x degrees. Well, add 180 minus x to x, the x's cancel, you're left with 180. So the sum of the measures of two supplementary angles is 180 degrees. All right, next is complementary angles. Here the sum of the measures of two complementary angles is 90 degrees. So if we have two angles here, one is 60 and one is 30 degrees, add those two angle measures together, they add up to 90 degrees. So that's complementary. Also, here's another pair of complementary angles here. One is 70 and the other one is 20. Add those two together, you're going to get a right angle of 90 degrees. And then also x degrees here for this angle. And then the other angle is 90 minus x. Add those two together. The x's cancel. You're going to be left with 90 degrees. So the sum of the measures of the two complementary angles is 90 degrees. Okay, next we'll look at transversals and angles. And I do need to explain what a transversal is. Anytime you have a line passing through another pair of lines, that's considered to be a transversal. So this line here is a transversal. Here's another transversal right here with two parallel lines. Okay, because it's got two parallel lines or two lines that are cut by a third line. And that third line is called the transversal. And when you have two lines that are cut by a transversal, you have special types of angles here. Let's say interior angles is the first one. So if you look at this one, angle 2, angle 4, angle 5, and angle 6 are interior angles. Those are the angles that are on the inside of those two lines. Here's angle 2, angle 4, angle 5, and angle 6. They're on the inside. This is the interior. And those angles are considered to be interior angles. Well, the opposite of interior is exterior angles. They're on the outside of the two lines. Angle 1, angle 3, angle 7, angle 8 are exterior angles. Then next you have alternate interior angles. And the word alternate means that these two angles are on alternating sides of the transversal and those two lines. So in this case, angle 2 and angle 5 are alternate interior angles. Also, angle 4 and angle 6 are another pair of alternate interior angles. Those angles are on alternating sides of the transversal and they're on the inside of those two lines. And then we have alternate exterior angles. In this case here, angle 1 and angle 7 are alternate exterior angles because the angles are on the outside of those two lines and they're on alternating sides of the transversal. On a similar note, angle 3 and angle 8 is another pair of alternate exterior angles. They're on the outside of those two lines and they're on alternating sides of that transversal. Then we have corresponding angles. Those are the angles that are on corresponding sides of the transversal and those two lines. So here angle 1 and angle 2 is one pair of corresponding angles. Also angle 3 and angle 4 is another pair of corresponding angles. The same holds true with angle 5 and angle 7. That's another pair of corresponding angles. And also angle 6 and angle 8 are also another pair of corresponding angles. Each pair is on corresponding sides of the transversal and those two lines. Now let's look at some properties that a property that deals with angles and parallel lines. If any two distinct coplanar lines, are cut by a transversal, then a pair of corresponding angles, or a pair of alternate interior angles, or a pair of alternate exterior angles are congruent, if and only if the lines are parallel. Okay? That's the important property that you have to be familiar with corresponding angles, alternate interior angles, and alternate exterior angles. They're going to be congruent if and only if the lines are parallel. And you must have two distinct coplanar lines being cut by that third line, which is called the transversal. Okay. Now we will be dealing with constructing parallel lines because usually with constructions there is technology that deal with how to do these type of constructions here. But if you were to construct parallel lines, what you'll have to do here is place the side of the triangle ABC on line M, and then use a ruler on the same side of line segment AC, keeping the ruler stationary, and then slide ABC, which is your triangle, along the edge of that ruler until its side AB, which will be marked A prime, B prime for the line segment contains P. And then you'll draw that line L through P parallel to M. Okay, so in this video I want to discuss a lot about parallel lines, how to construct them, because technology like the geometry software and also GeoGebra, those are the two technologies that are used to construct to do constructions in general. Okay, next is the sum of the measures of the angles of a triangle. The sum of the measures of the interior angles of a triangle is always going to be 180 degrees. Okay, let's say we have triangle ABC. If you cut out these pieces of the vertices of the triangle and then try to lay them out like this, they should lie out to a straight line. And in a straight line, the angle measure is always 180 degrees. So in this case here, the sum of the measures of the interior angles, those are the angles that are on the inside of any triangle, is 180 degrees. So in this example here, in the framework for a tire jack, ABCD is a parallelogram. If angle ADC of the parallelogram measures 50 degrees, what is the measure of the other angles in that parallelogram? And now let's take a look at this here. We have ADC, which is this angle that I'm marking off right here. That's 50 degrees. We want to find the measures of the other angles in that parallelogram. All right, now let's think about this for a moment here. If I want to find this angle right here, there is a property that says here, if you have a parallelogram, that means that the opposite angles are equal to each other. So if this angle right here, ADC, is 50 degrees, then angle 2, the measure of angle 2, will have to be 50 degrees. Okay. Now, if I want to find the measure of angle 1, here's the measure of angle 1 up here. There's also a property that says here, if you have two consecutive interior angles, they're supplementary. Meaning, the measure of angle 1 and this angle measure add up to 180 degrees. Supplementary means that the sum of these two angles is 180. And there's a property that says that if you have two consecutive interior angles, in fact, these are two consecutive interior angles. Also, angle 1 and angle 2 is a pair of consecutive interior angles. They're supplementary. They add up to 180 degrees. So if I found that the angle 2 was 50 degrees, then angle 1 will have to be 180 minus 50 degrees, which is 130 degrees. And then I can easily find out what angle 3 is by comparing 2 and 3. That's a pair of consecutive interior angles. They add up to 180 degrees. So if angle 2 was 50 degrees, then angle 3 must be 130 degrees. That's 180 minus 50. Also, I could have found that out by comparing angle 1 and angle 3. That's in a parallelogram, a pair of opposite angles are always going to be equal to each other. Okay. All right. Another example would be this. In the figure, M is parallel to N and K is a transversal. Explain why the measure of angle 1 plus the measure of angle 2 is 180 degrees. Okay. Now this pretty much introduced what I just got through talking about on that last slide. All right, in this case here, M and N are parallel to each other. Here, angle 1 and angle 3, which is way up here, are a pair of corresponding angles. And when we have two parallel lines cut by a transversal, that means that a pair of corresponding angles are going to be equal to each other. So the measure, if the measure of angle 1, okay, well, we don't know what angle 1 is. So here, corresponding angles means that the measure of angle 1 is equal to the measure of angle 3. And then compare angle 2 and angle 3. They're supplementary. So here, the measure of angle 2 plus the measure of angle 3 will be equal to 180 degrees. Well, the measure of angle 1 is equal to the measure of angle 3, so if we substitute in place of the measure of angle 3 with the measure of angle 1, we're going to get the measure of angle 1 plus the measure of angle 2 equaling to 180 degrees. This is the type of proof to show that if you're given two lines that are cut by a transversal, you want to prove that the measure of angle 1 and the measure of angle 2 are supplementary to each other. And this is the kind of a proof that supports our statement or claim. All right, next we'll look at the sum of the measures of the interior angles of a convex polygon with n sides. In this case here, the sum of the measures of the interior angles of any convex polygon with n sides is equal to n minus 2. That quantity will be multiplied by 180 degrees. Let's say we have a convex polygon that looks like this. Not the best. These are your interior angles here. If I want to find the sum of the measures of those interior angles inside this polygon, I would use that formula, n minus 2. N is the number of sides. Subtract 2 from it, whatever that is, multiply by 180. So let's say this one has 6 sides, so that means we're going to do 6 minus 2 times 180, or 4 times 180, which is 720. So the sum of all the angle measures of the interior angles in that convex polygon would be 720 degrees. Now suppose I want to find the measure of a single interior angle of a regular polygon. Then I would use this formula, n minus 2, quantity is multiplied by 180 degrees, and that whole thing is divided by n. So if I want to, and this is going to be of a regular polygon. That's very important because in a regular polygon, all the angles are equal to each other. Okay, next is the sum of the measures of the exterior angles of a convex polygon or a convex n-gon is always going to be 360 degrees. If you were to extend all the sides of that polygon to get their exterior angles measures, if you take the sum of each of the individual exterior angles, it's always going to equal 360, no matter what. Here's an example. Let's find the measure of each interior angle of a regular decagon. Okay, so in this case here, we find and a decagon has 10 sides. So to find the sum of the measures of the angles in that decagon, we're going to do 10 minus 2 first. That's going to give us 8. And then 8 times 180 will give you 1440. So that's the sum of the measures of all the angles in that decagon, 1440. And it's a regular decagon, so it's 10 sides, so take 1440 and divide that by 10 to find the measure of each of the interior angles. So for each interior angle, that measures 144 degrees. Part B. Find the number of sides of a regular polygon, each whose interior angles have a measure of 175 degrees. Okay, each interior angle has a measure of 175 degrees, so that means that each exterior angle is 5 degrees. Here, the interior angle and the exterior angle add up to 180, so subtract 175 from 180, you're going to get 5 degrees. So each exterior angle is 5 degrees. And if the sum of those exterior angles in that convex polygon is 360, then divide 5 into 360, you're going to get 72 exterior angles, which means there are 72 exterior sides. Okay? Each polygon has the same number of angles and the same number of sides. Another example with parallel lines is lines L and K are parallel and the angles at A and B are as shown. You want to find X, which is this angle here, the measure of angle BCA. Okay, and here's how they work this one out. What they did was extended BC and obtained the transversal, which is going to be line BC. That's going to intersect K at D. The marked angles at B and D are alternate interior angles, so they are congruent, and that means that the measure of angle D is going to be equal to 80 degrees. Okay, and as you can see here, if you were to extend this, look at B and look at D. Those are alternate interior angles. We talked about alternate interior angles. Their measures are going to be equal. So if angle B is 80 degrees up here, then angle D must also be 80 degrees. And we know A is 60 degrees. So if you look at this one, ADC form a triangle. So here the measure of angle ACD must be 180 minus the sum of those two angles, 60 and 80, which would give you 40 degrees. And notice that angle ACD, which I'm marking off in purple, and angle X form the straight line. And a straight line has an angle measure of 180 degrees, so subtract the 40 from the 180 degrees, you're going to get 140. Okay, and that will conclude this particular video on the more things about angles, which include the special types of angles.